So up to this point my focus has been on generating overscan using focal length. And as we know, adjusting the focal length, although it's got some very distinctive benefits, what it does do is it changes the parameters of the projection camera so that it no longer mirrors the shot camera. So our next investigation is going to concern creating an overscan by reformatting the image area. This is essentially a compositing workflow that transcends matte painting and camera projection, and I believe it's widely held within the visual effects community. But I feel that there is some justification in exploring this as an alternative to creating overscan with focal length, and probably undertaking some kind of comparison. My primary justification for that is that the method itself doesn't change the characteristics of the projection camera, therefore it should carry some specific advantages. What I would say about the focal length method is it's something that can be done in any of the previously stated software packages, because they all carry tools and properties for aspect ratio, resolution and focal length. Overscan generated in that way will transfer accurately between those packages. Conversely, reformatting by image area is very much contained within the compositing application, so if the matte painter is confident that the projection can be undertaken entirely from within Nuke, then this would be a viable approach. But if there was a possibility that they may need to migrate part of their workflow into Maya and then do some additional work and then come back into Nuke, then this is not a method of overscan that would transfer between the two applications. So I'm going to look at two scenarios for this. One where the plate, which we can see here, if I just look up here, when we actually take a render of this and we commit this to sort of the center of a matte painting, the first scenario will be where the plate actually stays within the center of that wider matte painting, and then a little bit later on we'll look at how we can offset that within the confines of a larger canvas, so that the plate itself doesn't sit centrally. And we'll discuss later on what the advantages are for that. Okay, so I'm going to start for this in Photoshop. You can see I've got my original plate image that was rendered from frame 50, and if we go into image size we can see that that's currently 1280 by 720. Okay, what I'm going to do is I'm going to increase the canvas size. I'm just going to increase it to some arbitrary value. So I'm going to set that to pixels, and I'm going to make it, let's go something like 2680 in width and 2200 in height. Okay, I'll just zoom out so we can see this a little bit more clearly. Okay, so with the focal length method we had to be mindful of the aspect ratio and took a lot of care to prevent rounding errors. With this method there's absolutely no need to even give the slightest thought to the aspect ratio. Okay, now in this particular case I don't know the aspect ratio, but you can see that this is much more square than any of the previous examples. This is probably nearer to a 1.2 aspect ratio than it is a 1.777, etc., because it is much nearer square. But in any case, that's kind of arbitrary. Okay, now what I'm going to do next is I'm going to bring an image into this, which is again an arbitrary image, which is just this checker map, which I've created as a smart object, and I'm just going to scale that up to fill the space. So this is really an arbitrary image. It really doesn't matter in the slightest what this is. It's just that I want to be able to see some image around the boundaries of my plate. So I've just dropped that behind the plate part of the layer, so that's sat. And you can see now what I meant about central. Our plate, which sits here, is central to that to the now what is the larger matte painting. So I'll save this file out. Again, I'm saving out to my project. There they all are. Wondered where they'd gone. So this is the matte projection on frame 50, and I'm just going to append it with the resolution that we've just applied. So what was it? It was 2680 by 2200. I'll save that. Okay, so I'll come back into Nuke now, and I will bring that matte painting in. So I'm looking for the 2680 by 22. Here it is. So we've now got it in, and we can look at that through our viewer now, and we can see the image is indeed 2680 by 2200. So I'm going to plug that into the Project 3D node, and something that I've already done, but I'm going to demonstrate, is that the projection camera is basically a copy of the projection camera at frame 50. So in fact I'll do it again just to demonstrate this. So I'm copying and pasting that, connecting it up. We're on frame 50, so even though this has got animation, as soon as I kill that animation, then the attributes will remain from that particular frame. I'm going to give it my customary blue colour, and I'm going to call it projection camera, and just append it with the frame name of 50. So we know that this is fresh, we know that the focal length is mirroring, and all the other optical elements are mirroring the shot camera. And ultimately that's one of the main advantages of this method, is that we don't have to change any of our optics, so our optics are staying consistent with the shot camera. Okay, but in terms of testing this projection, we can see here that this is absolutely not even close to lining up. Okay, and this is because Nuke is essentially squeezing the entire image into the projection area. So the workflow really is to reformat the matte painting image back down to the native 1280 by 720 resolution. So that's what I'm going to do. I'm just going to put a reformat node in here, and that will automatically take the root format, which is set in the project settings, which is to my advantage in this particular case, because the root format is 1280 by 720, so I don't have to go into here and manually look for that value. It's already in there as the root format, so I can just leave it at that. Okay, which doesn't appear to have made any difference to this. And the reason for that is that the image is still being resized, and this is not what we want. And in this particular case we don't want that, so we're going to change the resize type to none. And what we should see now is we should see the image jump into place. So because the image had been scaled down from 2680 down to 22 to 1280 by 720, we've actually just eliminated that by setting the resize type to none. So the canvas is still there, but the image size is now accessing our root format of 1280 by 720. But I think it's still useful for me to demonstrate that those coloured pixels from that checkerboard are still present. So I'm going to demonstrate that. So here's my reformat. I'm just going to type T to add a transform node in there. And I'm just going to drag this to the side a little bit, and there you can see that the checkerboard pattern is still there. If I come downwards, you can see that the checkerboard pattern is there all the way around this particular image. So the data hasn't been lost, it's being computed, and it's there to be accessed as soon as the image actually sort of goes into the boundaries of the display area. Okay, so if we take a look at that in 3D, we can see what that does. So we can see in the reformat by setting that to none, we can see how that brings the image back to its native size. But because the image is centered in the middle, then it occupies the center of our frame perfectly. So the takeaway here is that Nuke's got the ability to retain pixel information beyond the size of the display, but hide them until they're needed. Okay, so I'll just get rid of that transform node. And I think it might be useful for me to come back into here, and I think it might be useful to show the same basic workflow using Photoshop. I think many people have a better understanding of Photoshop, so maybe it'll help to consolidate your understanding of what's going on in Nuke. So I'm going to select the contents of this layer. So if I just hold down Control and then click on the layer, you'll see I get the marching ants around there showing that I've got a selection there. Okay, now I'm going to enable the crop tool. You can see that puts the crop boundary around there. Just want to focus up here. This is the crop menu, and you can see that we've got an option here called delete crop pixels. Now if we leave that checked, then it's going to basically get rid of all this information out here that we don't want to get rid of. This is our map painting area, so I need to uncheck that. Okay, so I can hit the return now, and that image is now cropped. So essentially it's changed the canvas size, but it hasn't deleted the pixels outside of the boundary of the plate image. And just to show that, if I just turn off my plate layer, you can see the contents of the other layer are sat underneath. See that all that information is there. So that's exactly what's going on in Nuke. All we're doing is changing the canvas size. Okay, I'm just going to come back and I'm just going to undo that process because I'm going to want to access this image later on when I show another approach to this same method. So let's carry back on in Nuke. So this is where we left off. We've got our map painting in position. We've got this reformat node. What I'm going to do is I'm just going to add a grade node in here, and I'm going to do that just really so that we can and I'm just going to put a lift or something on the red channel. I find it useful to be able to distinguish between the layers, particularly when I've got two exact layers in this position, or I will have later on. So just putting that cast over will just enable me to be able to differentiate one from the other. Just bring a bit of yellow in as well, just to sort of make it more orange. Okay, so I'm just going to come back into this. I'm just going to set this back at the scanline render, and we're just going to take a look at the reformat. Okay, and we've got an attribute here that I particularly want to draw your attention to, which is called preserve bounding box. Just what happens when I click this? I don't know whether you can see it. I don't know whether it shows you particularly well. Okay, maybe I need to be more directly linked to it to see it. That's it. So we can see the range of the bounding box here. We can see how that's extending out beyond the boundaries of the plate. So what this is doing visually is it's telling us that the area inside the display is the file size, or the canvas size in photo speak, and the dotted line and the contents that are within this dotted line is essentially the image area. So if the preserve bounding box is checked, then Nuke isn't computing the area outside of the display, so the pixels are effectively deleted. But if this is checked, as it is now, then Nuke is computing the area, and therefore the pixels are accessible. So if I just switch back to the scanline renderer, I guess the problem here is that our pixels are still not coming through. In fact, if I put it on the merge, we should see this even better. So if I just drag this back in time before the camera reaches its bottom position, we can see I've got a big chunk of area up here where I'd be expecting to see my checkerboard pattern, but I'm currently not. And this is because of an attribute inside the Project 3D node. So I'm just going to open the Project 3D node, and you can see that there's a crop attribute inside the 3D node. So I need to uncheck that, and you'll see that when I uncheck that, now I see my checkerboard pattern. Again, if I just flip over into 3D and we can see what's happening there, we can see that what that crop is doing is basically doing exactly that. When it's unchecked, obviously it's not cropping the area to the display. When it is checked, then it is cropping that. But obviously we need it unchecked because we need to be able to access all this information outside of the boundary of the screen. Okay, so all well and good when the image is in the center of the frame. But what if it isn't? I mean, at the moment we've got this huge area. We've got all these pixels out to the left, we've got all these pixels out to the right, we've got all these pixels up here that are never seen. The camera pans down, so we'd expect to see, oh no, the other way around, we'd expect to see all this information up here. We don't expect to see any of this down below or at either side. So effectively what we've got here is a lot of wasted space. This translates into data which has to be processed, and that's loading into preview time and render time, as well as sort of increasing the size of your asset resources, and it's unnecessary. And this is one of the advantages of being able to offset the plate in relation to the matte painting, is that you can be much more efficient in terms of the pixels that you want to display. So again, if we just take a look at take a look at this, and I type T to bring a transform node, you can see that the center of the image is right in the middle of the file area. So the transform node certainly gives us quite a strong clue. If we take a look in the reformat node, we can see another attribute. We can see this attribute called center, which is currently checked. And what that means is if it is using the center point of the image, it's basically using that to reformat the display size. So as long as we add an equal number of pixels to the top, the bottom, the left and the right side, then it's going to basically stay in proportion. It's going to stay like this because it's going to add the values equally to either side of the resolution change. But of course, in this scenario, what we want to do is we want to offset this plate so it isn't sitting in the middle of the screen area. So there isn't, if you like, an equal number of pixels on either side. Let's say that we want a lot more pixels on the top because we're actually going to pan the camera down, and therefore we're going to drag this image down, and therefore we're going to reveal a lot more pixels that would be typically up here. It means we don't need any pixels down here, or virtually no pixels down here, or at either side. We've just got a straight sort of pan down to reveal more of the pixels at the top. So we have a few extra steps to go through, but because this allows the matte painter to be very economical and precise about what they're projecting, it's definitely worth adding to the arsenal. So I'm going to come back to Photoshop. I'm going to come back to this image. Again, I'm going to hold down Control and select my plate layer to make sure that's set, and then open up my crop. Make sure my delete crop pixels is not on there, and then I'm going to accept that. And again, if we turn that off, we should see that our checkerboard is still there behind there. So we know the pixel data is in situ around that image. So now I'm going to increase the canvas size, but I'm actually only going to increase it by 50 pixels on either side. So this will go from 1280 to 1380, and this will go from 720 to 820. And you notice we've got our anchor here, and because the anchor is set to center, then that is going to put an equal number of pixels all the way around, so we're going to get 50 on either side. And you can see there that that reveals the checkerboard pattern behind, so we know that that's still there in the cropped area. Okay, so I'm now going to open up the canvas size again. This time I'm going to do something slightly different. I'm going to change my anchor to the bottom of the image, so now it's locked on, and it's going to scale the size from that particular anchor point rather than the center. And now I'm going to change the height to 1200 and choose OK. So now we can see that we've got a lot more pixel data at the top of this image, and we've got relatively small amount around the outsides, just really enough to give us a little bit of contingency. So I think I'm going to save myself this image now. So File, Save As, and I'm just going to append it with the resolution. So in this case we are 1380 by, I believe that's right. So that is now saved. Aha, no it isn't. Saved it as a Photoshop file by mistake, so I'm just going to save it again. I'll keep the same name, but this time I'll save it in my OpenEXR format. Okay, and I'll bring this in and then swap it with my with the one that I had before. Okay, I will keep that grade because that grade will be useful for being able to see the difference when we get the two image sets together. I'll keep that grade just to put that cast over. I don't need that anymore. But I will get rid of the reformat because we need to do the reformat again. Before we do that, let's just commit some of those numbers to our backdrop node. Our original was 1280. We increased that by 100 pixels on either side, so it went from 1280 to 1380 and 720 to 820. So we have our left side with 50 pixels. We have our right side with 50 pixels. we have our bottom with 50 pixels, and then we have our top. Okay, and the top is the interesting one, because to calculate this, what we need to do is we need to divide the new height by the original height. So let's just get the calculator. This is fairly simple maths. I could do it without the calculator, but just to demonstrate this. So our new height is 1200 minus the original one, which was 720, which gives us a difference of 480, and minus the 50 pixels that we've got at the bottom, which is 430. So that is our new top. So I'll copy that and close it. And there are our values. And our overall resolution at the end of all that is 1380 by 1200. Okay, jolly good. Okay, so let's put our viewer back on the merge node and just check that we're on frame 50. Okay, and we can see here again that the two images are clearly not lining up, and that's really to be expected given that we've shifted the plate off center. Okay, so what we need to do is we need to add a new reformat node to our matte painting. So I'm going to put a new reformat node in there. Again, in the properties, I need to keep it at my root format of 1280, but I need to set the resize type to none, and that obviously changes the canvas size without changing the image, as we said before. This time I need to turn off the center attribute, because it's the center attribute that's causing the thing to lock onto the center at the moment. So if I turn that off now, then our image is now basically finding a new anchor point. So if we just come and look at this through our scanline renderer, we can see on our image now this is obviously bypassing the plate, so we're not actually seeing the plate, we're just seeing the scanline renderer, and we can see from the center position there to the new anchor point here, it's now found a new place, and the default place to anchor from is the bottom left. So what we're seeing here is the plate locking onto a new anchor point at the bottom left, plus the 50 pixels that we've got at the bottom and the left side of this image. Okay, so to fix this, we just add in a transform node in here, which sits below the reformat, and then all we need to do in here is we just need to append our position on the X and on the Y by 50 pixels, and we should see there that we've now got our image back in position. So hopefully now I should be able to test this by looking at this over the merge, and we can see the color correction there from our grade node. So we can see the area that is our matte painting, and we can see the area that is our original plate, and we can see that as this moves through, we can see that's moving through just nicely with it. And hopefully if I start to toggle the merge node on and off, you can see apart from the colour change, there's absolutely no difference between the two. They're perfectly locked onto each other. Okay, so I'm going to wrap up here. I think what this workflow utilises common nuke nodes and properties, and has a specific advantage of not affecting the characteristics of the projection camera. So providing we can complete the full shot from within Nuke, this has got to be faster, more flexible and more efficient. The limitation is that we wouldn't be able to transfer our overscanned image back and forth between applications. But if we're confident that that wasn't going to be necessary, then this is definitely a viable choice of workflow.